Good evening, friends. Myself, Pratik Shirsath, and I'm here to teach you about some quality content about evaluation matrix. So, let me first tell you about myself. Um, I am a Golang developer and I'm ML enthusiast. So, without any wastage of time, let us start uh, for the content we are going to study about. So, what we are going to study about in today's session is what is evaluation matrix, the types of evaluation matrix, which are classification matrix and the regression matrix. Now, for to tell you about more about evaluation matrix, these are some primary types of evaluation matrix. Then we will learn deep inside what is evaluation matrix, why are evaluation matrix used, and further the classification matrix and the regression matrix. So, what are evaluation metrics? Evaluation metrics are nothing but the quantitative measures which are used to assess the performance of the model. So, not only this, but they also determine how well the model performs in terms of accuracy and precision. So not only this, but also it mm, it it measures that is it suitable, is the model suitable for the deployment or not. Now, you may question yourself that why why the evaluation metrics are used. Okay, why evaluation metrics are used, as I've earlier discussed, that it is used for the performance, to check the performance of the model, and not only performance of the model, but to see that the um, model is going through all the stages, one by step, in a very sequential manner, and it gives the output which is expected to it give. Not only this, but it will also compare the different models. If I have different models in my stack, so while I have different models, I will get the evaluation matrix on each of the model, and then I will take the outcome of each of the model, compare the outcome with all the models, and based on the outcome, I will check which model performs the best, and I will select the best performed model from that group of models. Not only this, but is also used to identify the weaknesses into the models. Now, the weaknesses are nothing but the accuracy, precisions. Not only this, but also it is used to avoid the overfitting and underfitting. Now, to tell you about what is overfitting and underfitting, mm, let me get you through the just a second. Let me present it. Yeah. So, yeah. So for an underfitting model is nothing but a, let me show you by the graph. Here are all the data points. These are the data points in a graph I'm plotting, and the regression line that in a linear regression we studied earlier, the line which it draws is this. That is, it poorly identifies the model. Now, underfitted models are the models which are trained on the training set very poorly, and the testing set they are also trained very poorly. So the outcome they gives are in a very scattered manner and not with the expected outputs. Now, these are the underfitted models. Now, what are the next? These are the overfitted models. This phenomena is called as overfitting. This is called as underfitting. Now, what are the overfitted models? Overfitting is a phenomena which happens into the training of the model when a certain model is trained on a training set so many times that it visualizes the patterns without analyzing the data, and it performs very well on the training set but performs poorly on the testing set. So this is somehow the graph I get when I train the model. For example, I have these many points and this. So this made the point. It exactly goes through the pattern, and somehow it performs poorly on the testing set. And the data, the model which we use, the model which we prefer is this. is somehow goes through the model but not crosses all the data points. It crosses the data points, but it also leaves the some errors. Some errors are expected by the model. There are no such models that never makes an error. So this is somewhat we call as overfitting and underfitting. Let us go to the PPT again. So yeah, so these are the reason why we use the evaluation matrix. Now, how do evaluation matrix helps in machine learning? Evaluation matrix helps in machine learning. How? Now these evaluation matrix becomes or helps like a guide to the data scientist in what do we say in managing the accuracy, precision, recall, and these factors are very important when we talk about model evaluation, model presentation. These are the things which we have to work upon. If we are not working upon these things, then our model will not work as we want to. So these are the things. And not only this, but they also help in choosing the right algorithm. For a model to have a right algorithm is as important as choosing the like if a model does not have a right algorithm, it will not give the expected result. Now let us move on to the next slide. This is types of evaluation matrix. Now the types of evaluation matrix consist first, that is classification matrix. Now what are classification matrix? Classification matrix, as stated above, the classification matrix are used to evaluate the performance of the classification model. Now what are classification model? Classification models are nothing but that includes the data which are classified into numerous labels. Okay, there are labels. For example, if I have a data set of cars, now the cars data set includes many more classes. The classes such as SUV class, that is the sedan cars, the sports cars, then what do we say, hatchbacks, and hybrid cars. Now, these are all the types of the cars which are included in the car data set. Now, this example, that car example, car data set comes into the classification matrix in which we classify each car into its specific type. Example, uh, which example, if I make a uh, email detection model, the email detection model detects the email into two categories: spam emails and not spam emails. Now let us see when is classification matrix used. Now the classification matrix are used for the categorical data. As I have discussed earlier, the data which have classes which can be further defined into number of classes, number of labels. At that time we use the classification matrix. Okay. Also it is used while learning the super also it is used while working on a supervised learning task. Okay. Not only this, now let us go to the further topic is confusion matrix. Now confusion matrix falls under the classification matrix. Okay. Now what is a confusion matrix? Now rather than telling you about more of the bookish language, let us focus on what is confusion matrix. Confusion matrix, if I want to state what is confusion matrix, I will state it as a table which contains four main components. Now, what are those four main components? First is true positive, the second is true negative, the fourth is false positive, and the fourth is false negative. Now, what are these? And we will see what how does it helps. For of now, look at this diagram. The positives and positive meets. When the positive and positive meets, it's called as a true positive. When the model predicts something as positive, but in actual the data is negative or the instance is negative, then we said it we can say it as a false positive. When the model predict something or some instance as a negative, that is it does not evaluate into a good thing, then we can say, but in actual it is a positive data, then we say it as a false negative. And the last but not the least is negative, true negative. Truly negative is nothing but when the model predicts that it is negative and in actual it is negative. So this is nothing but the true negative. uh, to tell you, if you have not understood, let me get you through some examples. So let me take you to my iPad. Give me a second. And yeah, so what do we have to do now next? The topic is confusion matrix. So let us confusion matrix. Now I will draw a simple box, four boxes, no issue. The this will be my actual outcome. Okay, this will be my predicted outcome. Predicted outcome. Now, for example, as I've earlier discussed, let us take a model. Now, which model? The model which, example, spam detection. Okay, email spam detection model. Now, what does the email? This is email detection model. Now, what does this email detection model do? Email detection model do. Okay, email detection model specifies or classifies, to be more specific, classifies the emails into not spam, and the second is spam. Moreover, faulty and not faulty love. Okay, so there are in actual, the message can be, the email can be spam email, spam, and the second is not spam. In similar ways, the model can predict the email into two ways: spam emails and not spam emails. Simple. Now, when the model predicts that a email is spam and in actual the email is spam, then we say it is a truly positive. That is true positive. It is correct. The prediction that is made by the model is correct. The model predicted a email as a spam. Prediction was correct on basis of the actual outcome. Okay. So this is the true positive. Now the second is when the model predicts the email as spam email, but in actual it was a not spam email. At such times, it is false positive. Okay. Now let us come to the third one. At the time when email is a not predicted as a not spam email, but it is in actual a spam email, at such times it is called as false negative. And the fourth one is are which is the important one, is the model predicts an email as a not spam email and in actual it was a not spam email, so it is truly negative. Now, in these four components, what are the two components we have to look upon and we have to evaluate more carefully? These are TP and TN. Okay. Now, higher the value of TP and higher the value of TN, it inculcates that or it indicates that your model is suited or your model fits onto the particular data which you are using. Okay, the algorithm which you are using is correct, or in short, just understand that you are on the right track. Now, having the value FP and FN are more like a not good. You're not in a good direction. So lesser the value of FP and FN, um, greater is the possibility that you may achieve your goal. So it is important that your model should have the FP and FN in a lesser quantity. Understood? Now there are some measures also to control FP and FN. To tell you about FP, that is false negative. You can also increase the threshold. Yeah, first measure to increase to handle the FP, handle FP, handle FP. You can increase threshold. Why not? You can increase the threshold. Increasing threshold is nothing but for an email. If the threshold is 50%, so what happens is the email which are predicted as spam but are not actual spam get into the FP values. But if I increase the threshold, at such times the FP will decrease, and which will help in our handling the FP. The second is increasing the feature selection. Feature selection such as to check is the email sent by the address authentic email, or also the link from which the emails are getting. The words keywords also may play a very crucial part in feature selection. Keywords such as let me write here feature selection, and I will tell you the word feature selection. What are the words? Words like congratulations, bear with my handwriting, and the second is many more like that. If I'm not wrong, congratulations and all. They're more like a spam messages. Now this is nothing but a confusion matrix. Now I hope you have got what confusion matrix means. So let us go to our PPT and see what is waiting for us. Now the important coming part is what is accuracy. Yeah, what is accuracy, precision, and recall. Now these again falls under the classification matrix itself. Now what is accuracy? Accuracy, again, the bookish knowledge. It measures the proportion of a correct prediction in the total prediction. Basically it is nothing but, so basically it is nothing but what it is. It is a ratio of correct prediction to the false, to the total number of predictions. So if you wait, huh. So let me go to, no, we will cover it all. So accuracy, again, it is a ratio of correct prediction to the total number of prediction. Now correct prediction, as I have earlier discussed, correct predictions were these: truly positive and truly negative. These were the correct predictions. Okay, here the message was spam and it was actually spam. Here the message was not spam and in actual the message was not spam. So these two blocks are the correct predictions and these two blocks are the false predictions. So correct prediction, the ratio of correct prediction to the overall prediction, matlab summation of TP plus TN plus FN plus FP. Simple. Then comes the precision. Precision is nothing but evaluates the accuracy of the positive prediction made by the classifier. Now it is very important to understand what is precision. Now people sometimes have a slight confusion in what is precision, what is recall. It is very important. Now when I say this, just focus on what I'm saying. Precision evaluates the accuracy of positive prediction made by the classifier. It is nothing but, what is it? Ratio of TP upon TP plus FP. Ratio of TP, okay, ratio of TP upon TP plus FP. Okay, this is TP plus FP. Now this block is nothing but, it evaluates that from the positive prediction made by these are the positive prediction which is positive. So from the total positive prediction, this column, these both rectangles are nothing but the total positive prediction made by the model, positive predictions. So from the total positive prediction made by the model, how many predictions were actually correct? So these are the actual correct and these are the remaining one which were false. So this is nothing but the precision. Okay, it focuses on the positive predictions made by the model. And what are this? Recall is also known as a sensitivity or true positive rate. Now this true positive rate will come up on the next concept also, so understand it very carefully. So it is the ratio of the number of true positive predictions to the total number of positive prediction instance in the data set. Now what is it? TP to the ratio of TP plus FN. What is it? TP divided by TP plus Fn. Now what is TP? TP plus Fn. Now this is nothing but from the actual positive, how many, these are the actual positive, these are the actual positives. Actual positive column, how many instances were correctly classified by the model? This is the answer, truly positive. This is nothing but our answer. So these are nothing but, of course we will also deep into this into by solving some questions, but let me go through this last concept, then we have a easy peasy example to solve. So what is it is, F1 score is the harmonic mean of a precision and recall. Now first of all, let me tell you what is harmonic mean. Harmonic mean, for that, again I have to switch back to my iPad screen. Give me a minute, less than a minute, sorry. So what is it? Harmonic mean. Uh, yeah, har- harmonic mean. Now, how does a harmonic mean state? Harmonic mean is nothing but it is a ratio of total number of instances or total number of components divided by the reciprocal of that component. Now for example, I take five numbers: one, two, three, 4, and 5. These are the number I have. For example, okay, any these are nothing but data points. Consider it as a data point. So, what will be the formula? Total number of, what do we have? Total number of components divided by the reciprocal of sum of reciprocal, pardon me, sum of reciprocal of each component. So 1 by 2, 1 by 3, 1 by 4, and 1 by 5. This is nothing but my harmonic mean. Okay, now to come upon how we got this formula, f1 score, f1 score का formula क्या है? It is nothing but 2 into recall into precision divided by recall plus precision. Sorry, precision. How do I got this formula? So understand that precision, the recall and precision are trade-off of each other. Now, what do you mean by trade-off? Trade-off is nothing but अगर एक बढ़ेगा तो एक घटेगा, and if the other is increasing, then the other one has to decrease. So this is nothing but the meaning of trade-off. So let us focus on F1 score has two main components. Two main components. What are those two main components? Precision and recall, sorry, and precision. Okay, so these are the two main components. So how many total number of components do I have? These are two. So total number of components divided by the reciprocal of each component. Now what is the first component I have? Take any one, doesn't matter. So what is it first? First is recall. So reciprocal of recall, now beside writing is recall, I will just name it as R, and 1 upon reciprocal of precision, that is 1 upon P. If I solve it, this will be, if I'm not wrong, P plus R upon, what is it? P into R. And if this goes up, this will be 2 into PR upon P plus R. So this is nothing but our formula which we have got. Now, what our PPT says next? Let us see. Let us jump to directly to a what do we say? Example. From that example, you will. I hope that you will get what I want to say. So let us focus on what is the example. What is it? Imagine you have a machine learning model that classifies email as a spam or not spam. Okay, this is the first one. Now let us assume that you test the model by 100 emails, 100 emails, and 80 emails. At the 80 emails are true. What are the correctly classified? Yes, that is a combination of TP plus TN, and what is the next? 10 emails, 10 spam emails, sorry, 10 spam emails misclassified, misclassified as not spam, which is nothing but my false negative, and the last is normal email classified as spam emails. This is nothing but my false negative, false positive, false positive. Okay, so I have taken up the values. Now let us jump to the iPad. Yeah, done. Yeah, you are able to see. Now this is the data we have got. Now what will be my accuracy? Accuracy is nothing but corrected predictions divided by the total number of predictions. So this is TP plus TN divided by, this is summation of that, TP plus TN plus, what is it? FN plus FP. So that will be, what are this? Total 80 emails divided by, if we add on 100, simple maths, this is nothing but 80% of the accuracy. I will talk upon what can be the specific what will be threshold for accuracy of the model. Okay, after that the model is considered as a good model, and below that the model is considered as a bad model. But for now, let us go to the next topic, that is precision. Precision, that is TP upon, if I'm not wrong, what does precision means? TP upon TP plus FP. So what is it? TP was my, for here, let us take my TP as 45 and uh, TP as 45 and 35 as my TN. If I'm not wrong in my math, yeah, it makes the total of 80. So what is TP? TP is 45 divided by, what is it? TP plus FP. What is TP? 45 plus FP. FP is 10, so 55. So this will give me more like 81.8, if I'm not wrong. Yeah, 81.8%. 81.8% of precision. And without looking to the next thing, I will tell you that my recall will be same as that of 81.8%. Now I will tell you the reason why I have, without calculation I have did it. Okay, trust me guys, when I'm saying this, I don't know this example. This is a spot on example, I don't know. So this is recall. What is recall means? Recall is TP upon TP plus Fn. So again, if I calculate these values, put up these values, it will be 81.8%. Okay. And lastly is F1, F1 score. F1 score will be my 2 into, what is precision? 81.8%. And this will be again 81.8%. What is it? Into, if I'm not wrong, yes, into 81.8%. Again, 81.8% plus 81.8%. Okay, this will again give 81.8% if I'm not wrong. Yeah. Now, to give you this example is to understand key, there might be some conditions where the precision and recall and F1 score might have the same values, and this is only at such times when your data is balanced. Okay, by the means of balancing the data is nothing but your Fn is equal to Fp. Having a balanced data is very important in model evaluation. No, not only model evaluation but not model presentation. Okay, when you get up the data, you clean the data, you process the data, but at such times you have to take care that not only that the data should be balanced. Now what does balanced data means? Now when I'm training the model, for example this email model, now when I'm training a model for that email detection, now when I'm bringing 100 emails onto the model, the model what does model do? Model processes the email. Now from that emails, I do not have to take the proportion in an imbalanced way. For example, 20% of my emails will be spam, not spam emails, and the 20% of the emails, 80% of the emails will be the remaining one. Not that. If we have certain number of, okay, because if you take this proportion, 80%, 20%, what will these do? Is nothing but if it is not spam and this is spam, what will the model do? Model will again and again, because most of the data is dependent upon 80%. Yeah, so it will again and again configure this percent, and gradually it will decrease the ability to identify the spam pattern, due to which you can get different measures, if I'm not wrong. And that, therefore we use a balanced data. Balanced data is nothing but the model will be in the practice to identify a email into a spam email and also into a not spam email. So this is a nothing this. So yeah, to have a balanced data is important. Now what? ah Accuracy. As I told about accuracy, 80% of accuracy. Or do you think that 80% of accuracy is good or not? So it varies from model to model. For example, if I have a model for cancer detection model, now cancer detection model is a very what do we say? Um, High responsibility model, because the life of people are dependent upon that model. So the model has to be very much accurate to 100, but it cannot be 100 as we know. So near to 100, 96, 96, 95 to 96%. should be the accuracy. Again, the different models are ADAS. If anyone car enthusiast is watching this, he might know what does ADAS means. Okay, ADAS are nothing but the smart drive control in the cars, which helps the car detection of car accidents. Okay, now car accident models. Now these models are also very important. Now these models have to be so accurate that it will save the people's life and prevent the accident. So also the precision should be high. But in the cases of email email spam detections, so 80% is quite good, uh, I assume. Not only this, now let us move to the next part. We have what is waiting for us. F1 score is done. Now, now comes the big man, ROC and AUC curve. Now, what is ROC and AUC curve? ROC and AUC curves are nothing but in machine learning. ROC curve stand for receiver operating characteristic curve, is a graphical representation of the performance of a binary classifier. Now, it is very important to understand that ROC curve has two components: true positive rate and false positive rate. What does a true positive rate means? True positive is nothing but the ratio of TP upon TP plus Fn. Now, this is the time that you have to recall what you have studied in the previous few minutes. TPR is nothing but the precision. Okay, false positive rate doesn't mean anything. Okay, but it is the new terminology we are learning about. So, false positive rate is Fp divided by Fp plus Tn. Now, let me go to an example for a ROC curve. You will get it how ROC curve works. So again, the same procedure. Let me go to my iPad screen. Yeah, so let us start. For example, now to give a better example, let me give you an example of, let us consider there is a society in which people lives. Now there are 10 peoples, very small society. But let us see. Now these 10 peoples are, from the group of these 10 peoples, there are some peoples which are infected by a virus. Let us take a very virus which we all know, COVID virus. Yeah, COVID-19. So some of the peoples in this 10 people of group is infected by the COVID-19, and some of are not infected by the COVID-19. So what we will do, these 10 people goes to a doctor. Okay, clinic, if I'm not wrong, this is clinic. Okay, now in this clinic there's a doctor. Now what does the doctor do? Doctor performs some test. Of course, we all know that some test. Okay, नाक में bird डालते थे and all. Now these tests are conducted upon the people, and based on that test, the conclusion was drawn. Okay, now there are some tests. Okay, um, let me draw a regression graph on that. Now linear regression graph in which a S curve is there. अच्छे से नहीं बना यार, ढंग का बनाते हैं. Yeah, so the highest value is 1, lowest value is 0. Okay, this is y-axis, this is x-axis, this is actual data, more like input. This is nothing but the predicted data. Okay, now these 10 peoples have done some prior tests, and based on that I have managed them to set these datas onto the x-axis. Now this is not a part to think upon, but let me do that for you. These 10 peoples are on the x-axis. For example, 1 2 3 4 5 6 7 8 9, this will be 10. Okay, now for the one, these, let me write these actual values. What are these actual value states? Actual value gives the idea that these people are infected by the virus or not. So the first one, is it? No. Then second one, yeah, no. The third one is yes. Fourth one is no. Then this is yes, this is yes. Then again, no, no, yes, yes. Now if you go through it again, it's a balanced data. 5 numbers, no. 5 members, yes. So this is the data. Now at such times, these are the predicted values and these are the actual values. Now if I go through the S curve, I get the predicted value for each data, again each data, again each data, so like each data. But what if I don't want that predicted value? What if I want the conclusion? Okay, now what if I want the conclusion that if a person is infected by the virus or it is not infected by the virus? So at such times, what do people do? A common technique. What is it? Introducing the threshold. Now threshold is nothing but above that threshold. Okay, threshold is nothing but a line. Okay, mean line. So let me draw it. This is my threshold. Let me t. Now what is it? On the scale of 0 to 1, my threshold is set at 0.5. Okay, now above this the prediction is yes, above this the prediction is no. Got it? Simple funda है, कुछ hard नहीं है इसमें. Now let me draw a, what is it? Yeah, confusion matrix. Confusion matrix, either TP, either TL, either FP, either F. What is it? Eraser. This is FN. Yeah, FN. Now for this model, yeah, are you able to see? Yeah, for this model, how many values are actually positive? This is positive, this is negative, this is positive. How many values are positive, predicted positive, and actually positive? Now actually positives are this. Total five people are positive. Five people are positive. Now I will see that how many points fall under the yes section and how many y fall under the no section. Now the y falling under the no section, I will not take it, and the y falling under the y section, I will take those. So this, it falls again, this one. Okay, this is one. Then of course this also, these all four y's falls under the predicted yes part. And this y where it goes here, that is in the negative. So total number of y's 4. Total number of y मतलब total number of peoples which are predicted positive and were actually positive. तो 4 लोगों को तो सही से उसने प्रेडिक्ट किया है मॉडल ने. अभी मॉडल ने प्रेडिक्ट तो किया बट दे वर एक्चुअली नेगेटिव. सो हाउ मेनी आर दे? एक्चुअल नेगेटिव कितना है? लेट मी पॉइंट आउट. 1 2 3 4 5. एंड from this how many were predicted as positive? How many were predicted as positive? Let me undo this. Wait. So these were 4. So how many are actually negative but predicted as positive? So this no, this no. Yeah, total 2 no, 2 peoples were actually negative but predicted as positive by the model. So from these many, 2, that is 2. Of course लिख दिया मैंने 2. फिर उसके बाद क्या है? This is negative, I'm sorry. Yeah. From that again, now predicted as negative but actually were positive. The people were positive. Now where are the people which were actually positive? This is yes, this is yes, this is yes, this is yes, and this is yes. Now from these people, which are the people were actually which are predicted negative? ये पॉजिटिव है बट प्रेडिक्ट हुआ है क्या? नेगेटिव नहीं, ये तो यस में जा रहा है. ये जा रहा है कि नहीं? दिस वन नो, दिस वन नो, देन द रिमेनिंग इज दिस. नाउ द लॉजिक इज, अगर 4 पीपल, टोटल मेरे पास 5 पीपल थे, 5 पीपल में से अगर 4 पीपल आर ऑन द अपर साइड, दैट द रिमेनिंग वन विल बी डाउन द वन. ओके, logic. The second is 2. Now what is it? The people were actually negative and predicted negative. So this is 3 peoples. Now on the basis of this regression model or this regression graph S curve, we have got a confusion matrix, and in that confusion matrix we have got all the values for all the 4 components. Now on the basis of this, we will get what is TPR and FPR. Okay, now for the TPR, what will be 4 upon 1 plus 4, that is TP upon TP plus FN. Yeah, so it will be 4 upon 5. If I'm not wrong, this will be 0. 0.8. Yeah, and इसके बाद FPR में क्या है, this will be 2 upon, that is FP upon FP plus TL, that is 2 upon 2 plus 3. This will be 2 divided by 5. This will be 0.4 if I'm not wrong. Now this part, as I've done for 0.5, the threshold was 0.5, I will do for at least 4 times या 5 times, so that I get a graphing points. Okay, ROC के लिए मुझे points चाहिए, and on what basis I will get the points? On the basis of the threshold. Now तुझे अपने को threshold ज़्यादा नीचे आगे ऊपर करना है. Okay, we have to decrease the value, increase the value, so on. Okay, now this was first case where my T was 0.5. The second case, if I'm not wrong, now this process is little time consuming, so I will directly write it. Okay, this is one, but this is a very important case to understand. Now when my T is 1 मतलब इधर आ जाएगा. When T is 1, ऊपर तो कुछ नहीं आएगा, बिकॉज एस कर्व के ऊपर कुछ भी नहीं आता है, सो इधर वाई सेक्शन तो आएगा ही नहीं मेरा. सो ओनली रिमेनिंग सेक्शन दैट आई हैव इज नथिंग बट एन, दैट इज नो सेक्शन. सो दिस सेक्शन, the y erases, the y erases, this also the no erases, this also erases. हाँ, and ये एक line है, this is my S curve and S curve, yeah, S curve आया. इसके बाद this is my threshold and this whole part will be my no part. So no part इधर है. So for t is equal to 1, my confusion matrix will look like 0 0 5 5. Now what is this? TP. This is TN, this is FP, and this is FN. Okay, and for this I will get some values. TPR is equal to and FPR is equal to. See, I just want to tell you the reason why here 0 and 0 I have written. Okay, now why 0 and 0 I have written? This is nothing but positive and positive. Positive and positive is nothing but they were actual positive and predicted positive. Now what is it? Actual positive, this 5 yes, and they were predicted as positive. Now in this case, do I have a section where there is a threshold which segregates two parts, that is yes and no? No, I don't have. The threshold does not segregate, it only have the no part. So prediction yes का हो ही नहीं रहा है. So if the model is not predicting yes, then I cannot write anything rather than 0. So it is 0. Then इधर क्या है? Negative. So predicted positive हुआ है but actual में negative है. Actual में negative है. Actual में negative. There are 5 ends. 1 2 3 4 5. Now this 5 ends are predicted as positive. Again, predicted as positive matlab y section. Again, in this threshold I do not have the y section, so again 0. And these are the same two things which I have done earlier, so not to talk upon that much more. So how will this will get 0 by 5 and this is 0 by 5. Okay, this will be nothing my 0 and this will be my 0. So it is important to understand, for t is equal to, threshold is equal to 1, t will be the TPR and FPR will be 0. Then the most important, again the important is t is equal to 0. For t is equal to 0, let me draw confusion matrix. The confusion matrix, what will confusion matrix? T is equal to 0 मतलब इधर. अगर मेरा t is equal to 0 इधर है, if my threshold is 0, if my threshold is 0, then what does it? Threshold इधर है, threshold के ऊपर वाला part होता है हमेशा y, that is yes, and the down part is always no. If the threshold is here, I do not have my down part. Okay, the no part is not existing. The only part that exists is yes part. So इधर क्या हो जाएगा अभी? उल्टा. This will become my yes part. This will become my yes part. Okay, simple as that. So इसका ही उल्टा बनेगा. T1 का जो आया था उसका उल्टा. So this will be my 5. This will be my 5. This is 0. This is 0. Okay, just to explain, I will explain you. Okay, positive मतलब क्या है? The actual predicted as positive and actual positive. Actual positives कौन से थे? 1. This is 1. Then 2. This is 3. This is 4 and this is 5. Now anything that is above this line is nothing but yes, that falls under the yes conditions, so this is nothing but 5. Then predicted as positive but were actual negative. Actual negative कौन से 1 2 3 4 5. Now these were actual negative but they are predicted as yes. This is nothing but the line above the, this section about that, above the line. So this is nothing but y section. They also falls under the y section. So again, how many falls? All of them. So I will write 5. Okay. Now what is the formula again? TPR will be my 5 upon, if I'm not wrong, yes, 5 upon 5, and FPR will be my 5 upon 5. This will be our 1, again 1. So the last part, let me take another random, if I'm not wrong, 0.9, and let me give it a random guess for this point. TPR, if I'm not wrong, this will be my, yeah, 0.6 and 0.4. Yeah, these are the random guess. Okay, this is not a very much important thing, important point to be noted upon. This is nothing but I want an extra point on my graph, so I'm taking it as t is equal to 0.9. But now let us plot the graph. This is my graph for ROC, y-axis, x-axis. This is my TPR, this is my FPR. True positive rate, false positive rate. Now this is my 0. Okay, now first is, what is it? 0.9. 0.9 is, of course, this value is from 0 to 1 and this is from 0 to 1. 0.9 FPR is 0.6. 0. Is something here? Yeah, 0.6, 0.6 and 0.4. If I say that this is 0.5 and 0.4, then here something? Yeah, yeah. T is equal to, T is equal to 0.9. Okay, then similarly I will plot these. T is equal to 1, T is equal to 1, and T is equal to 1, this is 0, and TPR and FPR both are 0. This will be here. T is equal to, what is that? T is equal to 1. Then the T is equal to 0. T is equal to 0 is the extreme point where these are the, this is the extreme most point which I can get in the ROC curve. So this is T is equal to 0, where my FPR is equal to 1 and TPR, FPR is equal to 1, FPR is equal to 1 and TPR is equal to 1. Nice. And the last point is 0.5 wala, if I'm not wrong, 0.5, 0.5, TPR is 0.8 and FPR is 0.4. TPR is 0.8. TPR is 0.8 something here and FPR is 0.4. No? So 0.4 will be something here. Yeah. T is equal to, what is it? 0.5. So this is my somehow graph. This is the graph. Okay. Now it's very important to understand. This is my ROC graph on which I can do my evaluation. Now, these are the points. Now, which is the important point that I need to focus upon, that will decide what will be my the threshold. Now, depending upon this, it is very important to understand. We will choose the following point, the only point where my FPR is less and my TPR is higher. For this point, of course, it's not in the game only, तो उसको हटा दो. This TPR अच्छा खासा है. This is something kind of a middle, and TPR is कम. FPR तो है ही है. TPR भी कम ही है. तो we can go to the next part. TPR अरे अच्छा है यार, इसका TPR अच्छा है. But the FPR is also good. FPR is slightly less than compared to the TPR. TPR is good. Then this. Now here, most of you will think that why can't we take this point and not this? My suggestion is to take this point and not this point. Why? It is because जितना हमारा TPR है उतना ही हमारा FPR है. What does that means? Again the same thing. कि जितना तू सही कर रहा है उतना ही तेरा मॉडल गलत भी कर रहा है. तो it nullifies the effect. So it doesn't matter कि like इतने मेहनत करने के बाद you are getting nothing. Okay, so it's very important to understand that the TPR and FPR should not nullify each other. Okay, one of them should be greater, and one of them should be greater. In this case, always the TPR should be greater than the FPR. Okay, so we will choose this point. This is the ROC curve. Now, again and again, switching back to the PPT, I will just tell you what is AUC curve. AUC curve stands for area under curve. Now, area under curve is slightly dependent upon the ROC curve itself. Now, the area which is covered by the ROC curve is called as AUC curve. Okay, this is the curve which is covered by the this is the area. Okay, this is the area which is covered by ROC curve. Now this is the point. Now there are three types of graphs which we need to understand. There are three types of graphs which we need to understand in AUC curve. The first is, you all have got the idea that I have to go to this point rather than going to this point, because when I go to this point, when I'm going towards this point, it is very important to understand that when I'm going to this point, my TPR तो is increasing, मेरा TPR तो increase हो ही रहा है, but on the same side my FPR is decreasing. So ये win win situation है हमारे लिए. तो that TPR is increasing, increase होते ही जा रहा है, होते ही जा रहा है, होते ही जा रहा है, and my FPR is decreasing. So this is a win-win situation for a developer, for a model processor. Okay. So पहला पॉइंट क्या है? Let me take it to a extreme case कि ये इंक्रीज होते 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 सीधा इधर आ गया 1 पे अगर मेरा आ रहा है तो मतलब मेरा टीपीआर क्या है? ओके, मेरा वाई कोऑर्डिनेट क्या हो गया? एक्स कोऑर्डिनेट होता है और वाई कोऑर्डिनेट होता है, तो मेरा वाई कोऑर्डिनेट क्या हो गया? 1 हो गया, एंड मेरा एक्स कोऑर्डिनेट क्या हो गया? एक्स कोऑर्डिनेट अगर मैं इधर स्टैंड कर रहा हूं तो मेरा एक्स कोऑर्डिनेट क्या है? 0 ऑफ कोर्स. So this is nothing but it. What does this depicts? It depicts this graph. The graph which I'm showing right now. This. So ये जो graph है, which covers this much of area, okay, is called as a perfect classifier graph. A perfect classifier मतलब सब तुम्हारा सब सही है. Your model is not making a single mistake in predicting the values, but of course it is not possible. But yes, whenever the value is going towards the FPR and decreasing towards the TPR, and the value of FPR is decreasing, then you are winning, my friend. So you get first. The second is when AUC is equal to 0. This is nothing but my AUC is equal to 1. The second is AUC is equal to 0. Now when my AUC is equal to 0, AUC is equal to 0 is nothing but the opposite of this. This will be my AUC is equal to 0. This मतलब क्या है? मेरा पॉइंट इसके पास जा रहा है, इसके पास जा रहा है. rather going to this, मेरा पॉइंट क्या कर रहा है? मेरा मॉडल कुछ अलग ही बिहेव कर रहा है, वेरी वियर्ड. FPR के पास आ रहा है. So going towards FPR is not a very what do we say, condition that is observed or that is likable by all the developers. Okay, then again the next is now what is the next point? This is the middle case where 50-50. This is 50, this is 50, as I earlier discussed. This is AUC 0.5. Now what does this AUC 0.5 means? AUC 0.5 means the same, the previous graph which I showed you, the इधर जो बनाया था मैंने. Now what does that means? वही कि आधा सही कर रहा है तुम्हारा मॉडल और उतना ही तुम्हारा मॉडल गलत कर रहा है, तो इट ऑफ कोर्स नलिफाइज इफेक्ट. सो अभी देखो इसमें सो ये पॉसिबल तो हो नहीं सकता, बट वी वांट दिस. सो एनीथिंग दैट फॉल्स अंडर दिस कैटेगरी, लेट मी टेक दिस कैटेगरी फॉरवर्ड. फॉर एग्जांपल, my model can if my model is looking like this, if my model is looking like, if I have a curve here, then here, this is my something model ROC curve. So तुम देख रहे हो क्या, my bending, my the curvature जो आया है मेरे ग्राफ को, that is bending towards, what is it, bending towards this side ना. So it's a positive sign that is going towards that. The TPR is decreasing, na? A TPR is increasing and FPR is at the same time decreasing. प्लस प्लस मेरा एयूसी ग्राफ बढ़ रहा है। जितना एयूसी ग्राफ बढ़ेगा, जितना टीपीआर बढ़ेगा, जितना एफपीआर घटेगा, उतना मेरे मॉडल के लिए अच्छा है। नॉट ओनली दिस, बट फॉर एग्जाम्पल इफ अ मॉडल, this is the last example and then we will move on to the further topic. So this is the model. Wait, so this is my model, this is the another model. Okay, now if a same model is trained on different algorithm, for example एक पे ट्रेन हो रहा है, एक मॉडल पे मैंने लगा दिया रैंडम फॉरेस्ट एंड दूसरे पे लगा दिया मैंने लॉजिस्टिक रिग्रेशन। तो एक वाला आरओसी दिया मुझे ये वाला ग्राफ, फॉर एग्जांपल दिस, इधर से इधर गया मैं, इधर से इधर, इधर से इधर एंड इधर से इधर। दिस इज माय फर्स्ट ग्राफ, आर ओ सी ए यू सी ग्राफ, graphs for both this and this. Okay, ये हो गया मेरा first. And the similar model when I uses a random forest model, random forest algorithm, at such times this is here, 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 this is here. So it morely gradually bends towards the TPR. The TPR goes on increasing. Okay, तो जितना मेरा TPR increase हो रहा है उतना मेरे लिए अच्छा है. So we will use which algorithm? The random forest, rather than using the logistic regression. We will not use the logistic regression, but we will use random forest algorithm. Okay, this helps. Okay, ये सब पॉइंट्स कवर करने के बाद ही हमें समझता है कि whether to use this algorithm 1 or algorithm 2. Okay, so a model that selects a better algorithm works better, and who helps the model to select the better algorithm is nothing but the evaluation matrix. Evaluation matrix में कौन सा ROC curve, AUC curve and all the other factors. Okay, now this was slight bigger topic, but yes, it was to be, what do we say, covered. So yeah, now we will say what we have the next. Regression matrix. So regression matrix. Now what is a regression matrix? Again, regression matrix in machine learning, regression matrix are used to evaluate the performance of the regression model, which predicts continuous values rather than the discrete values. Okay, continuous values and regression model में use होता है. Now why are regression metrics used? Now regression metrics are used where we have continuous regression, continuous values again and again and again and again, goes on increasing. They are in a sequential, or rather than in a what do we say, intervals of period. There are continuous values in it, and yeah, similars are that it guides the data scientist in, rather than picking up the weakness. It helps to improve the data efficiency, data processing efficiency, and not only this, but it also helps to increase the components like accuracy and precision, and not all, and more on. The topic coming up is, the topic coming is MAE, that is absolute mean error. Now, for you all, must have studied what does mean absolute error means, but again, leaving the bookish knowledge, we will focus on what does it means. Okay, again, we all know that it is the absolute difference between the predicted value and the absolute value. Yeah, we all know that, but it is very important to know that absolute mean mean absolute error is very important while we have to evaluate a model. Okay, if you this is the formula, of course. Yeah, this is the formula. I will go on defining all the terms, and then I will take these terms on my iPad with a specific example. So let us move on to the second one, that is mean squared error. Mean squared error में क्या है? The average of the squared difference between the, this is nothing but you have removing the absolute value. This is nothing but the modulus function. Modulus function ये क्यों है ये भी मैं बताऊंगा. Okay, now you are removing the modulus function and just you are squaring up the value. Okay, MSE. Now this is different metric. अभी सिंपल फंडा है कि अगर मेरे पास MAE नाम का एक मैट्रिक्स था, then why was there a need for introducing another matrix? Okay, this is also a very interesting topic to discuss upon, so I will tell you about that also. But let us go to the third topic, that is root mean square. Root mean square error is nothing but the square root of MSE. Okay, with the same units. It is very important. Okay, it is very important to understand the same units. It helps. Okay, it helps in communication. सेम यूनिट्स है, ज़्यादा कुछ फेर बदलाव करने की ज़रूरत नहीं है, जो ही आउटपुट आ रहा है वही मुझे लेके मुझे फर्दर टास्क के लिए डालना है, बस खत्म बात, ईज़ी। ओके, नाउ लेट अस where am I? हाँ, let us go to the iPad. Where is my iPad? Yeah, चलो स्टार्ट करते हैं। सो फॉर एग्जांपल लेट अस टेक एन एग्जांपल। ओके, खत्म हो गया, खत्म हो गया। सो लेट अस टेक एन एग्जांपल। फर्स्ट इज एम ए ई, मीन एब्सोल्यूट एरर। मीन एब्सोल्यूट एरर का सबको पता है क्या है क्या नहीं। ओके, दिस इज नथिंग बट what is it, summation, if I'm not wrong, yeah, 1 upon n summation I is equal to 1 till n, yeah, and this is nothing but modulus function yi minus yi cap. Okay, now this is nothing, now this of course predicted, this is actual, खत्म बात, इतना ही है। अभी इसके बाद क्या करना है आपको, इट इज़ वेरी इंपॉर्टेंट। नाउ एग्जाम्पल ही ले लेता हूँ मैं पहले। एग्जाम्पल क्या होगा, फर्स्ट इज हाउस नंबर। Okay, the predicted value, yeah, predicted value, and this is the actual value. First is one, house number one, house number two, house number three, and house number four. The predicted value for first house was 50 lakh, and the actual was 48, yeah, 48 lakh. Okay, ये कैसे लिख दिया मैंने, हाँ, 50 lakh and the 48 lakh. Then the next was my 70 lakh, and its actual was 75 lakh, more more than it. Then again 60 lakh, then this is 58 lakh, this is 90 lakh, and this is 85 lakh. Okay, simple. Now how will I plot these numbers? How will I plot these numbers? ये मेरा x axis, ये मेरा y axis, these are nothing my predicted, and this is my actual value. Predicted value, actual value, this is 0. Now how do I have to predict this? If I have a line, for example linear regression का line ले लिया मैंने, okay, if I have a linear regression line, okay, and for example if my this point falls under this category, this is 40 and this here, the second point that is predicted is 70 but actually 75, this falls, if I'm not wrong, yeah. So this falls under this part. Yeah, हाँ, इसके बाद 60 and 58, so this is 60 and 58, so 60 and 58 goes here, if I'm not wrong, actual was 75, no, so it will also come here, actual was 75, no, उधर ही आएगा, I'm sorry guys, I'm sorry, हाँ, so ये इधर आएगा, nice, इसके बाद 60 and 58 भी हो गया, and then 90 and 85, 90 and 85 will something, 90 is here and 85 is something here, so this is here. Now is nothing, this is nothing but what do we have to do, what do we have to understand is nothing but these are the points that were expected to be on this part but they are on this, these were expected to be this but they are on this. Now when we are calculating, when we are calculating, huh, when we are calculating a mean absolute error, what do we calculate? We calculate the distance, we calculate how much of error is there in the actual price and the predicted price. So it is very important to understand that some of the model uses a mean absolute error very commonly, because mean absolute error का advantages क्या है? Mean absolute error का advantage is that they have the same unit as in when you calculate MAE, जब आप MAE calculate करते हो तो what does it do? Mean absolute error देगा in which unit? In unit of what is it? Lakhs. So this will give you in lakhs. Any number you take. So it gives the output in lakhs, and it is the same unit which is similar to the y-axis. Y-axis was also in lakhs. So it has the same unit. First advantage is add one, H, same unit. It has the same unit है. The second is it is robust to outliers. Robust to what are outliers? Outliers are nothing but the values which are disconnected. Okay, these values are connected to this lines, show some relation to the predicted line. This is the nothing but the actual predictions, but this can be the outlier. The value which is far away from the mm, actual price, far away, कुछ संबंध ही नहीं है, कुछ कुछ है ही नहीं, but these are the outliers and it is very important to eradicate those outliers, because the if you are not eradicating the outliers, then um, your model will not process the outcome in the desired way. Okay, so these are the advantages. The second part is disadvantage. Due to the disadvantages, we use the mean square error. Now, what is the main advantage, the main disadvantage, if I'm sorry, the main disadvantage due to which the mean absolute error lacks in some point is nothing but it, the graph is not, what is it, differentiable. The graph is not differentiable is nothing but it has some points. Okay, it cannot be differentiated. The graph, if I'm not wrong, अगर मुझे ग्राफ बनाना होगा तो graph is not differentiable at 0. This is somewhat a graph for mean absolute error. Okay, and not only this, but due to this, we do not use the mean absolute error, but we use mean mean square error. Now, what does mean square error? Mean square error का आपने को formula पता है, is nothing but 1 upon n summation n. This is modulus. We have to remove the modulus function yi minus yi cap the whole square. This is nothing but my mean squared error. Now, while focusing upon mean square error, this is again let me take this only graph. Now, what do I have to tell you? This is gone. This is gone. This is, let me wait. Gone, gone, gone. Array, gone. Now, what do I have to focus upon? These are the points. Okay, same example, same graph, nothing is different. Now, when we calculate the mean square error, what do we actually calculate? Yeah, we calculate this area. We square up the area. We square up the area for each point. We calculate this again, this. अगर ये एरिया है, ये पॉइंट इधर है, तो दिस विल बी माय स्क्वायर एरिया दैट आई विल कैलकुलेट, एंड बाय कैलकुलेटिंग दिस ऑल एरियाज वी विल कंबाइन इट, एंड बाय कंबाइनिंग इट, कंबाइनिंग के लिए कौन सा फंक्शन यूज कर रहा हूं मैं, समेशन ऑफ कोर्स, देन आई विल कंबाइन इट, ऑफ कोर्स स्क्वायर करूंगा, स्क्वायर किया इसलिए तो इतना बड़ा स्क्वायर बना ना, then I will combine it, and then combining we will get the final outcome, that is mean squared error. Now, this mean squared error, mean absolute error are nothing but the errors which we have to reduce it. Okay, नाउ मीन स्क्वायर एरर है, मीन स्क्वायर एरर को अपन क्या कर सकते हैं, अभी इसका एडवांटेज क्या है? एडवांटेज इज दैट इट्स ग्राफ इज डिफरेंशिएबल एट ऑल द पॉइंट्स. अगर मैं इसका ग्राफ बनाऊं, then how the graph will be, it will look like a parabola. I hope everyone knows what a parabola means. So this is first, differentiable at all points. Simple as that. And what is it? Disadvantage. Disadvantage due to which we have to introduce the next term. Disadvantage. Disadvantage is that it penalizes the outliers. What does penalizes the outliers? If a point is located far away from a line, then it will have a bigger square. Now, let me show you. Let me take this point. Now, when I'm taking this point, okay, see the square, see the area that I have to cover. See how much area does I have to cover. It is lot much bigger than bigger than, like, it is bigger. So I have to find the area of this, square it up, and then combine to the remaining ones. Now what does it do? It again and again goes on increasing the MAE, and if the MAE not, it again and goes on increasing the MSE, and if the value of MSE increases, then what will happen? The error will increase. And basic logic है, अगर error increase होगा, then our model will not perform in the way we want to perform it. So it penalizes the outliers. Penalizes the outliers. Basically, it is not robust. It is not robust. Simple as that. Clear? Okay. Now, the last is root mean square error. Root mean square error similar. The main important. Okay, एक point रह गया, एक point रह गया. See, when you are focusing upon root squared mean square error में we cannot. The communication is hard. When I'm saying communication is hard, is nothing but when I'm calculating this error MSE, the output that I get will be in the squared form. Why it will be in the squared form? Because look at the squared function. It has a square function. For example, अगर मेरे पास CGPA is my y-axis and package is my x-axis, which is in LPA. इसका यूनिट है LPA. ओके, पॉइंटर तो CGPA में होता है, so it doesn't have any. So जब मेरा आउटपुट आएगा ना, तब मेरा कितना LPA आएगा, it doesn't shows the exact LPA, it will show my LPA square. So again and again I have to convert it. इतना करो, ये करो, वो करो. So at such times it is hard. Okay, it does not have same units. The same units were present in the mean absolute error. So it is very important to know this point also. I wanted to cover it, so I told you. The last is, that is third one, is root mean square error. Root mean square error is nothing but square of the same. That is square of mean square error. This is nothing but summation I is equal to 1 n. This is yi minus yi cap, and this is the whole square. This is nothing but my RMSE. Now, what is the advantage of RMSE? I'm not going to solve these examples because it's very easy, and mathematically it's very kind of easy maths that everyone can do. So I'm not going to waste my time in solving that easy problems. Rather than I will save the time and tell you that more information that I can share it with you. So what is the advantage? Okay, for root mean square error, the only what advantage it produces is nothing but similar as this. इसका advantage क्या था? Parabola, of course, great. It is very great. But along with parabola के साथ it also has same unit. Of course, अगर मैं root लगा रहा हूँ and they're inside a square, it nullifies, it cuts off, and then I get a normal unit. If LPA was my unit and in MSE मुझे यूनिट क्या आ रहा था? LPA square. But in the part of RMSE, if LPA is my y-axis unit, then what will be my main answer? Same, LPA, because root and square gets cut off. Simple. Okay. This is the. Now let's move on to the last concept of the today's session. Where PPT. This is the last concept, that is R2 square. R2 square. Let us go by the definition. What is say? R squared score, or the coefficient of determination, measures the proportion of the variance in the dependent variable that is predicted for the independent variables. Now what it does do now, it is very important to understand that what does it do. It tells you the how the model is performing, and it also explains that how it handles the variance of the variables. Okay, variance of the variable is nothing but it explains how the variance of the variable is handled. Now what is a variance, you will say? For example, um, let me move my iPad. Yeah, variance. Yeah, So what is variance? What is variance? So variance can be, let me take an example. If variance can be, if a house price is from $50,000 to 5 lakh dollars. Yeah, this is nothing but a wide spread between the area. 50,000 is a smaller value than compared to the 50 lakh dollars. So there's a lot of area covered between these. Okay, so this is nothing but spreading over all the data points over the graph is nothing but the variance. Jitna zyada spread, utna zyada variance. Okay, simple in terms to understand it. And so thus, therefore, higher variance. Got it, guys? And the second part, if the house price ranges from, for example, 2 lakh, no, not 2, 2 lakh, 2 lakh to 2 lakh 20,000, the spread is less. ज़्यादा spread नहीं हो रहा है number, okay? The data points are more over in a compact way, closer to each other. So at this time, this is nothing but lower lower variance. Simple as that. Okay, let us move to the next part. Now, in R2 score, it is very important to understand that what does it formula says. R2 score is 1 minus SSR divided by SSM. Now, what is this SSR and SSM means? SSR is nothing but sum of squared values in regression line. Now, what is this regression line? I will tell you in few minutes. And sum of squared values in, what is it, mean line. Okay, for this let us understand an example. Okay, for an example, let me take an example of CGPA. CGPA is plotted on x-axis, yeah, and the package is plotted on y-axis. These are two depending, okay, depending upon each other. Jitna zyada CGPA utna zyada package. Okay, traditional method, but yeah, let's forget about that. Okay, now what is it? Let us consider that we do not have the CGPA axis. Okay, CGPA axis abhi ke liye nahi hai mere paas. Only I have is the package. Now, for example, if I go to a college, for example, if I go to a XYZ college and go to a college and then tell ki I'm a freshie, I want to study here, and can you please tell me what is your package? Okay, if I study from this college, what package will I get? Now, of course, I have not studied there. मेरा CGPA नहीं है उधर, तो on what basis I will see the package that I can get? On what basis? Mean basis. Mean basis में क्या करूंगा मैं? लोग क्या करते हैं? They get a average package. You also have seen the average package nowadays. Okay, the colleges says कि हमारा इतना package होता है, उतना package होता है, but होता नहीं है. Never mind. तो average package कितना है मेरा? For example, let's say 3.5 lakh. 3.5 lakh. Very okay package, but so average package ये हो गया. But at such times, now let me draw a graph. As I've earlier discussed, my x-axis will be my CGPA, if I'm not wrong. Yeah, this is my package. Y-axis. This is my CGPA. CGPA is x-axis. Okay. Now, भूल जाओ कि मेरे पास CGPA है अभी के लिए, भूल जाओ. I only have package. तो package है. These are my points. Something. किसी को 9 मिल गया, बाप रे 9 मिल गया, चलो. किसी को 4 मिल गया, किसी को 3 मिल गया. This is my scattered data. Simple. And when I'm pointing out this 3.5, 3.5 ka aayega somewhere here. This is my y mean, and this is okay. जो था मेरा ये SSM is nothing but sum of squared values in the mean line. अभी ये जो वैल्यूज है इनका मैं एरर निकालूंगा from with respect to these lines. This again, this. Okay, got it? Simple as that. This is the first part. First part is what I have covered here. SSM. Simple. The second part, if I introduce the CGPA part, CGPA part introduce हो गया तो क्या हो जाएगा? अगर मैंने CGPA part introduce किया तो we will directly focus upon, तो easy हो गया ना कि जितना ज्यादा मेरा CGPA उतना मेरा पैकेज, जितना कम मेरा CGPA उतना कम मेरा पैकेज, वही है. तो तब मैं क्या करूंगा? इट इज वेरी इजी टू अंडरस्टैंड. अगर मैं दो वेरिएबल्स पे डिपेंड कर रहा हूँ तो इट कैन बी बेटर बी डिपिक्टेड एज रिग्रेशन लाइन. सो अगर यही लाइन है, या रादर देन शोइंग अप टू दिस पार्ट, आई विल गो हियर एंड ड्रॉ दिस लाइन. या लेट मी इरेज दिस. हाँ, सिंपल. ये हो गया मेरा रिग्रेशन लाइन. तो रिग्रेशन लाइन क्या दिखाता है कि इधर से मैं CGPA लिया, ओके, इंटरसेक्ट, दिस इज माय पैकेज. या अगेन दिस इज नथिंग बट माय होल थिंग दैट आई वांटेड टू एक्सप्लेन. ओके, ये क्या हो गया? लेट मी गो अंडू. हाँ, नाइस. इधर तक आ गए अपन. नाउ this is the exact graph that we have. Now this line is a regression line. This line is the mean line. Regression line depends upon two variables, CGPA, SGPA, CGPA and package. Okay, CGPA जितना बड़ा उतना मेरा package. Linear regression upwards, simple बात है. And the second is mean. Mean में क्या कर रहा हूँ मैं? I do not have something dependent value, only I have a single value. Single value में मैं क्या कर रहा हूँ? अगर if I have a bunch of ideas, okay, a bunch of packages, and I don't know that which exact package I will get, okay, without knowing my CGPA, then at such times what will I do? I will gather up all the data, okay, summation it all, and then divided by total number. मीन ही निकालना है, और मीन निकालने के बाद क्या आ जाएगा मेरा? मीन वैल्यू, दैट इज द एक्सपेक्टेड पैकेज दैट आई विल गेट. सिंपल बात. इधर तक आ गए. नाउ इसके बाद देयर आर 3 मेन टॉपिक्स व्हिच you have to understand in this. So what is this? You have to understand. So let us see. Yeah. So ये जो ग्राफ है मेरा, इसमें मेरा फर्स्ट आता है कि when, if I'm not wrong, आपको मैंने just a second, let we go to the so that you can see the formula. Yeah, so this is the formula is for SS total, and SS total is nothing but the SS mean. So what will be it will be that is y minus y cap summation, and this is for regression, and this is y cap for mean. Simple as that. Yeah. So let me go to my iPad again. Yeah. So this is the formula, if I'm not wrong. Yeah, it is the formula. Summation add करना है, मैंने summation add करना भूल गया, and इसके बाद 1 minus. Okay, this is my actual formula. Both the formulas are same. This is with respect to the regression line. This is with respect to the mean line. Okay, summation हो गया, खत्म. Now there are some, अभी it is very important to understand कि ये जो values है, they have some certain meanings. For example, जब r मेरा 0 है या r मेरा 1 है, so at such times they have some different meanings. Okay, now we will learn about that, what this means. Now it is very important to understand, जब मैं r calculate कर रहा हूँ तो 1 minus when my both the values are same. Now when I'm saying both the values are same, what it will be, if both the numerator and denominator are same, then what I will get, 1 minus 1, of course, huh? Because cut हो जाएगा तो 1 ही आ जाएगा, and if 1 minus 1, 1 minus 1 is 0, is nothing but 0. Yeah. And when I'm saying that the numerator and denominator are equal to each other, is nothing but the error that the regression line makes and the error that the mean line makes is similar to each other. So क्या होगा इधर, ये जो मेरा लाइन है, this regression line, it will come up on the mean line. सिंपल, समझ गया इधर तक? ओके. सो अगर जब मैं ये इधर आ रहा है तो व्हाट डू आई हैव टू डू? हाँ, अगेन वही है कि इफ अगर ये लाइन घूम के मेरे मीन लाइन पे आ रहा है तो मेरा आउटपुट किस लाइन के विद रिस्पेक्ट आ रहा है? वाई मीन के रिस्पेक्ट. रिग्रेशन लाइन का तो आ ही नहीं रहा है ना, मीन लाइन का ही कंसिडर हो रहा है. तो व्हेन आई एम कंसिडरिंग ओनली द मीन लाइन, बिकॉज the only line I am left with is the mean line, and when I have only mean line, then I am calculating my package with respect to the mean without having any CGPA. So at such times, it's no point of this, there is no point of doing so. So whenever R is equal to 0, understand that your model does not fits it, sorry, model does not fits. Okay, model is not correct. Indirectly model is not correct, your model is not performing as it want to perform. Check up some, कुछ तो गड़बड़ है, कुछ आगे पीछे कुछ तो करना पड़ेगा आपको. You have to figure out things and then make it correct. Now अगर मेरा r is equal to 1 minus, now if my numerator becomes 0, numerator becomes 0, तो क्या हो जाएगा? If numerator becomes 0 is nothing but SSR line does not have any error. SSR line मतलब this line, this line. The regression line means does not have any error. So let us solve 0 upon what is it, SSM. तो अगर ऐसा हो रहा है तो what does it means कि इसका एरर है ही नहीं, जीरो एरर. जीरो एरर मतलब क्या है? एकदम परफेक्टली परफेक्ट क्लासिफायर हो रहा है. परफेक्ट क्लासिफायर, इफ इट इज perfectly classifying all the data points, of course it does not all the times, okay, it is not practically possible, but at such times we get r is equal to 1, and it means that the model perfectly fits. This is the important thing to understand. Okay, तो कंक्लूजन ड्रॉ करते वक्त क्या आ रहा है हमारे दिमाग में? अगर मेरा आर स्क्वायर इधर है and if I set it up in a timeline from 0 to 1, so we want our model to go towards 1. अगर if it goes toward 1, good, you are on the right track. Okay, if it goes towards 0, gadbad, something is bad. Okay, your model will not perform efficiently. Yeah, सब गड़बड़ हो जाएगा. This is the only thing. And the last thing, okay, बहुत क्या बोलते हैं उसको, weird thing है. Okay, it is very weird thing to happen. It is if this thing happens, then understand that you have to practice a lot. But this is also the case, so I am covering it. This is nothing but the fourth case where my R2, that is R2 square, that is the R2 value. R2 value becomes negative. Now when can the value be negative? If the formula is 1 minus SSR upon SSM, matlab this value should be greater than 1. Logical. And how can this value be greater than 1? If my SSR is greater than SSM. Of course, SSR greater कब होगा? SSR is nothing but the sum of squared regression line errors. Now ये error कब होगा मेरा बड़ा? When these are the points, see these are the points, for example, रिग्रेशन लाइन ना, हाँ, तो मतलब मीन लाइन तो इधर से जा रही है, मीन लाइन इज डूइंग इट, उसका काम वो कर रही है, बट द रिग्रेशन लाइन वो कुछ अलग ही है, इट्स कमिंग अप हियर फॉर एग्जांपल. So it never ever counters any of the points on the graph. So at such times it has a high error, very high error than compared to the mean line. This is the regression line at such times. Simple as that. Okay. So at such times, if this is the case, then you have to understand that you have to practice a lot. You have to go through again and again evaluation, what is wrong, what is right, and you have to come to a basic understanding that your R should always move from point 0.5. Of course, point 0.5 can be the negotiable point, and point 0.5 से 1 की तरफ जाना चाहिए, not rather than going from point 0.5 to 0. Okay, I think this is the last topic which I have to cover, and I think I have covered it. Now let's move to the PPT if I'm not wrong, and yeah, so this was my side, guys. I have hopefully covered all the topics in evaluation matrix by so far, and I hope that you have liked it and you have understood what I have been saying for an hour maybe. Yeah. So it's been up my time. Thank you guys, and thank you for the lead and organizers to giving me this chance. Yeah. And do you have any doubts? Please let me know. Mm, I think so. You have understood very quite well. So thank you guys. Okay. Yeah.